Sure.
So thank you so much for the time and for accepting my request to be part of this discussion. So welcome on board.
Thank
And
you.
I would say to everyone who is on the call, thank you so much for joining. So let's talk, I would say, not like the hard talk, but the normal one. So what is happening on the RPKI front? Too many RFCs, too many drafts coming in. So are we are we um, are we at that level? We can say, is it mature enough or not?
No, I've said in the past, and let me say it here right now, that if you think the current state of BGP routing security based on RPKI credentials, if you think that is a good defensive shield, then it's about as good a shield as one that you can build from wet lettuce leaves. It's completely insubstantial. If any determined attacker can attack with ease, and they can, with the most rudimentary of path attack, stripping prepends, putting out more specifics because you got your max length wrong in the rower, then this is not defense. This is merely just a pantomime. But they say, the real trick is this is all about route leaks. I'm sorry, but quite frankly, if everyone else, all of you folk, have to go to enormous amounts of time, trouble, and expense just to save yourselves from my fat fingers, it's a lot easier just to chop off my fingers and stop me using the keyboard. If all of this is about defending ourselves against ourselves, then this is crazy, because the cure is substantially orders of magnitude more expensive than whatever the disease was. So in that respect, yes, I think there should be more RFCs, but I also think there should be a huge amount of more thought. We kidded ourselves with V4. We completely blindsided the industry. I think if you'd rerun this history, knowing what we know, you'd be mad to have deployed it even then. It was pretty crappy, entirely insecure, hardly worked, and wasn't really solid. But it was an accidental success. And we kind of kidded ourselves in the IETF that all successes are like this. We merely need to write an RFC. Wisdom prevails. The beauty and light of what operators should do will automatically win over darkness and ignorance. And, off we go, like, V6.
But
like,
you mentioned,
DNSSEC.
but you did mention that we have to work more on this one. So the work.
Well, I think most of these technologies actually are difficult. Don't forget, the issue about routing security dates back to about the same time as BGP itself. The first thoughts about this rumor-based protocol that actually works exactly like gossip. I tell you, you tell your mates, they tell their mates, and that's all it is. And there is no way easily that anyone who receives a random piece of gossip knows how true it is, because they got it from Peter, who got it from Paul, who got it from Mary, who got it from John, and so on and so forth. Where's the truth in that? Why should you believe this? And this was always going to be hard. It's going to be hard because you're not seeing the original data. The original data gets passed over one hop and then destroyed. And that BGP speaker creates a new piece of data that passes it to the next, and so on and so forth. And so when you think about what we conventionally know about security, everything about BGP works against it. Security is used to sign what's good. Oddly enough, and this was a wonderful RFC, and I think it was Steve Bellavins, the evil bit, that life would be so much better if the bad things on the network identified themselves as bad, and we'll reserve a bit in the IP header. This is a bad packet, because then our job is done. If the evil bit isn't set, we're good. But all we can do is tell you what's good. Now, if everybody marks good, then obviously if it's not marked, it's bad. Yeah.
Okay, so I get your point.
If only half the people mark what's good, the rest is kind of, well, could be good, could be bad. I don't know.
So you gave BGP 30 years to, right? And you're not even giving a decade to RPKI. And you're saying that...
I think RPKI is brilliant. I think BGP security is devilishly difficult. But let's look at what RPKI does as distinct from BGP. This problem dates back to, I think, a conversation I had with Paul Wilson. 98, 99. Whois is an amazing protocol. It's just ASCII lies. You have an open ASCII protocol, eminently, manipulable, and goes and asks an arbitrary DNS name, yeah, right, over an open insecure channel, yeah, right, sends it an ASCII thing and gets back some ASCII garbage. And this is the underpinnings of security. This is our registry. This tells you who owns what's address. This is real. Like, it's nonsense. And so what we wanted to do back then, and I think it was a really good idea, was to actually say, if I'm a registry and I'm holding data about you, then maybe what we should do is have some hard authentication of that data. And one of the best ways of doing that is to sign it digitally. Now, who should sign it? Well, maybe if it's data about you, maybe you should sign it and I should sign your key because you're the customer. So what if we had a registry that actually had digital signatures for every single entry signed by you? This gets interesting because when I get back the ASCII text and the signatures match, you said it. It's not a lie. You said it. You can't unsay it because you said it. This is your key that signed this. So now you have authenticity, irrefutability, timeliness, because it's got a date on it. And all of a sudden, instead of, oh, ASCII lies, the data about you is signed by you and it's the truth. And if you don't like it, change it and sign it again because it's your data, your address, your company, your this, your that. And what we wanted to do back then was to actually make Whois work. That when you got back something, you could go, is it signed? Can I validate the signature against the person and their key that was signed over by APNIC, the registry operator? Lock, lock, bang, bang, wonderful. Now, we thought what we wanted to do was not only sign you, but sign what addresses you held in our registry. And what we found, wonderfully, was an RFC written a long time ago, RFC 3779, that described an extension to a certificate that allowed you to add some attributes that said, here are a bunch of IP addresses. Now things are looking really interesting because now I can have a registry entry about you with addresses that we gave you, signed with a key that's your key, but the addresses are constrained by us. Those extensions are the addresses we gave you. Now, whenever I see that address, I can do a Whois query, find that those addresses are yours, Aftab, nobody else's but yours. You can't deny it. And all of a sudden, this becomes authoritative.
But it is still talking about the origin.
No, we're not talking about routing.
No,
I'm just saying, have you got that address? Now, what you do with it is your business. You can route it. You can shred it. I don't care what you do with it. I'm not the routing police, but it's your address. And now you have a way of proving it. So now you can sign something with that same key and someone wants to test what you've signed. They go to the registry, pull out the entry, find the public key and the addresses, and all of a sudden that's Aftab's addresses. they're his. It's not Geoff. I can't pass myself off and say, I own that address. Only you can say that now. This seemed like a really good thing, independently of routing.
I'm not disagreeing with you, but I have one question on, I have one concern on that one. So when people started working on the SIDR working group back in the days, if I'm not mistaken, 2006 or 7. So what came out of that is what the operators are using.
Okay, so warped and twisted history, and you have to unwind it a lot further than that. Because what had happened without an awful lot of money was Steve Kent had done a protocol analysis and had come up with a protocol called SBGP in the late 90s, early 2000s. And it certainly had pushed it around in a number of operator working groups, and it was mentioned at NANOG a few times. Cisco looked at it, and Cisco's basic response was, wow, this will melt the routers. Because a router is not a massive CPU engine, it's a massive switch. And there's not a lot of CPU attached, and all that crypto was going to be loaded onto the box, and this was going to be really expensive. And so Brian Weiss and Russ White came back to the IETF with almost a counter proposal called Secure Origin BGP, SOBGP. And it was a lightweight security. It was security light. It wasn't that the protocol was secured. No. It was an ability to constrain the lie because it talked about what was plausible, right? Now, both SBGP and SOBGP didn't have any way of understanding what is a real address. There was no foundation to it. It was all floating on thin ice. So SOBGP used a bizarre web of trust model, and SBGP just waved its hands a lot and said, we assume that there's something out there called a PKI. Now, the IETF sort of let it lapse. And part of the reason why is there was no money. So, you know, obviously router manufacturers do things that customers ask, but more to the point, they do things that customers pay for. And oddly enough, if customers don't pay for it, they don't build it. You know, it's all driven by customer demand. And what actually happened right up until that event that escalated into DHS land was that no one cared. And so it just went into abeyance. But with this renewed interest in cybersecurity, DHS turned its amply filled pockets to the problem of DNSSEC. And what they did was fund the research, fund the practice, fund the practitioners, hell, you know, fund everyone. And oddly enough, it gave it a kick that it was never going to get otherwise. There is very little DNSSEC out there today, but there would be none if DHS hadn't got involved, just absolutely none. Flush with this astonishing success of DNSSEC, the PI turned his attention and his money to securing BGP and started splashing a lot of money about. Now, this kind of bounced around, and at that point, it got picked up in the IETF circles. They'd been playing around in the usual way. Oh, it's all about requirements. So we had the Routing Protocol Security Requirements Working Group. Went on for years, got absolutely nowhere because personalities started head bashing. Not me, not this time. Personalities started head bashing, just unable to resolve. So CyberOps was founded out of frustration. And I think the ADs made a dramatically bad mistake. You can look them up if you want, or I can name them if you ask, but a dramatically bad mistake. Because when they started that working group, they insisted in the charter that the way we built security into BGP, we weren't allowed to change BGP. So you had to build this security as a weird bolt-on because we weren't allowed to change it. And now I think this was a reaction to the fact that for the past 10 years, we've been bolting on crap to BGP like crazy. the open negotiation of the capabilities. Can you do graceful restart? I could do graceful restart. Can you do 4-byte ASs? Can you know, what day is it today? Can you know what day it is today? And so on. And they were sick and tired, and I think a whole bunch of router vendors were sick and tired of bolt-ons into BGP. And so this time, CyberOp started, I think, hobbled. They, oddly enough, weren't allowed to work on path because there was no requirement. Oops. And they weren't allowed to change BGP. Oops. So what do? Well, inside that tight little room with only one door and no windows, and all that was left was Origin. And so off we went down a path of Origin, but we couldn't change BGP. Now, I think that was a mistake, but 2020 hindsight and all that.
Okay.
The reason why it was a mistake was that the bolt-ons aren't clean bolt-ons. They're a mismatch. You can see the join. And in a security sense, when you've got vibrating joining parts, you've got fractures of weakness, whether it's the mechanical world or the digital world. And so the edifice we've constructed is unstable.
Okay. Unstable, not insecure or unsecure, I would say.
It depends on
it does solve a problem.
It depends on your definitions. You see, there's a number of issues flying around the way credentials are moved and the way credentials are applied. So you sign ROAs, you have certificates, all these CRLs and so on. And the assumption is that everybody's products get to every BGP speaker that needs it before it's needed in their entirety. In their entirety. But the standards don't say how long that takes. What's the target time to disseminate across all those distributed repositories? Go figure. What do you do when you haven't got everything? Great question. Do I know that I've got everything? What's everything? And so you're meant to assemble the entire universe of credentials without knowing what that means, without having a checklist to know if you're missing anything, and then apply it to the entirety of BGP. And you're asserting by your comments, wow, this is perfect, this is secure, this is great. None of those are true. Because
so
we don't.
It's not great. I'm not saying it's great.
Good.
It is much better than what we had before, which was just relying on the IRR databases, querying them and looking up what is there. It was much garbage there, what we have today in the ROAs. Yes, I can't ensure, even today, sometimes if I'm running two relying party software and I compare the ROA dumps between each other, I do see differences.
So all this came out of need. I think every ISP, I was in an ISP at the time in Australia, people would come to us saying, route my net. You kind of go, yes. What does my net mean? Well, it's this number here, this prefix, router. Yes. Now, while we had about, 100 customers, life was fine. When we had about 1,000 customers, life was getting interesting. When we had a much, much larger number of customers, we had to process this particular piece of work. And so you're off consulting who is databases and sending email, and you could route anything. And it was horrible. And we wanted something in the provisioning system that gave us authority. And so this approach, because RPSL wasn't really about the authority of the record, RPSL was about the policy integrity. The authority of the record was missing. It was just who is. And so we started to work on this in CIDR, and it's great, but it's work in progress, not work finished. We're still just heading down this path, but a bit like V6, there's this cheer squad that says, you're finished, aren't you? You're finished. Aren't you finished? And the DHS was part of this. I'm sure you're finished now. Let's put it into product. Let's go test it. Let's go. It's kind of, wow, we're at stage one. There's probably another 9 to go, but you want to make this into a product? Are you mad? Because there was a lot more to do. I think a lot of those initial design decisions were ad hoc, but not final. In the same way that V6 doing multicast instead of ARP was kind of bizarrely stupid, and their treatment of fragmentation was just comical. There are a number of design issues, I think, with the distributed repository structure and the whole idea of a shared fate filter list to communicate to the router that were not well thought through and could have been severely tested and alternates thought through. But, you know, we have what we have because, yes, it's a product, isn't it? So you took some crap on the lab and turned it into a product and then wonder why it creaks and groans.
Okay, so I'm just going to read the comments from Roland Dobbins, where he rightly said that the RPKI isn't bad, but it only solves one problem, and we shouldn't be considering it that it solves the whole BGP validation problem set. So we have to stay realistic, and I think most of the operators are realistic that it is only solving one piece of problem, not everything. We haven't solved the path validation problem yet. There are a few good discussions happening, but of course, BGP-SEC is not one of them. But saying that RPKI is not going to solve any problem.
No, I didn't say that.
Okay, that's good. I'm going to record this and I'm going to share it with the world that you didn't say that.
Now, RPKI solves a whole bunch of issues we were having with whois. Oddly enough, we've never really gone down that path in much detail. It's coming up now with this work that we've been talking about for, 15 years, called AnySigner, where instead of signing these defined sort of BGP-defined objects, you actually sign a whole bunch of other data objects using the same basic, attached signature structure. Because what the real value was with RPKI was to give an authority model to the registries that says who has what address. Because otherwise, how do you know you've gone to the right registry and got the right data? I went to www.apnic.net. Yeah, right. And the DNS doesn't lie? Well, it's a secure channel. Yeah, there wasn't a man in the middle doing a proxy on you? Well, no, it's real. It's accurate because the registry is good, and no one managed to fool the registry. Where's the signature? Where's the authenticity? Because if everything's signed and you have the signature for your data, it's really hard for me, no matter who I am, to alter that data without your explicit knowledge and permission. I can't. And so RPKI actually gave us that solid foundation that said, if we really want to build anything to test assertions about addresses and their use, and that's the real aim in routing, it's the real aim in a whole bunch of things, assertions about addresses and their use, then the PKI was one good answer. Now, if you look at DNSSEC and compare it to a PKI, there's a legitimate question that goes, why did you add all this X500 paraphernalia? You didn't have to. DNSSEC didn't. But DNSSEC had an explicit authority model. We looked hard at the DNSSEC model of delegation, that a DNS name tells you where it comes from. Here's an IP address, 203.10.60.0. Where'd it come from? It doesn't have an explicit delegation model.
Because you excluded IANA from it. No,
the address has no parent in it.
I mean, it's just, you can't go back from the dot and then
there's the 203 and the 10 and the right. That doesn't work like that. It's flat. It's not a structured space, and because it's not a structured space, we couldn't use raw keys the same way DNSSEC did. So we had to impose a validation hierarchy. Why is this true? In the same way that X500 gives you that for all other kinds of areas where X500 is useful. So the decision to go to X500 here and use an X500 structured PKI was a deliberate decision. It wasn't just, oh, well, it's the only thing around. The bad fit we found is that the tools around X500 are not well suited to our environment. The whole idea that there are many thousands, tens of thousands of discrete publication points is an anathema. It just doesn't work very well. And the PKI models of X500 don't help. PKI models don't normally have long chains of CA to CA to CA to CA. They're very, very short and very, very flat. And I think we stretch the model close to the point where it breaks. And we're not even a big stretch. But, you know, it has been a difficult fit.
So just quickly moving to the next step, I would say RPKI is real. It's there. We are encouraging operators to create ROAs because it does solve some problems, not all problems. You mentioned one thing in one of your recent blog posts, outsourcing the validation part. Outsourcing if I'm an operator, I'm running my own relying party software, and then feeding the information, feeding the cache from the RTR to my router, and then it is making the decision. So you are suggesting to make public repositories of the relying party software, and then we just point our routers toward there?
God, no. Look, the best way to outsource validation is to use as a transit someone who validates.
So the top...
So, Mike, if I aim default at someone who drops all invalids, surely job done.
Of course.
My users can't go to anywhere bad.
So, I mean, for me, if I am a customer of an ISP who is a customer of Telstra, so I don't have to worry about it because Telstra is dropping invalid. So I don't even see it in my BGP feed at all.
As long as you're pointing default up there and you're not trying to play, you know, routing games, etc. But, you know, the whole issue is if you're a customer of a transit, you've outsourced a whole bunch of routing policy. And if that transit's doing validation, all your transits do validation, then you're never going to get past routes that fail because they're all doing it. And oddly enough, the number of users that we measure sitting behind such a wall of validation transits is actually really quite high. And so this whole idea that everyone should validate is, I think, yeah, because there's only 10,000 transits.
Validate, but everyone should sign their resources, so that everyone should create ROAs.
This is the whole, it only works best when everyone does it. And to the extent that origination validation is going to be meaningful, you got to have stuff signed in the first place. Absolutely. To the extent that that is a useful defense against deliberate attack, doesn't work. And you know, that's the conundrum. So the problem is
look at the number of incidents which is happening, right, on daily basis. And if you look at the list, what I can see, of course, I cannot see the intentions behind of those, but most of them I can see are very short-lived, and because of the fat fingers.
There's been a huge amount of work trying to classify BGP announcements. And I must admit, BGP is a bizarre zoo. You know, no matter what you look for, you will find it. No matter what pathology you look for, and any kind of known pathology or even unknown, folk route /31s in V4, you know, God knows why. You know, you see all kinds of perversions in AS path. You see every odd behavior under the sun. And in some ways, trying to classify, as you say, the motivation behind this is really quite difficult. To the extent that, what do we worry about? That's a different kind of question. because it's a bit like the whole V6 argument. And I suppose you have to forgive my cynicism of having lived through 25 years of hysterical V6 sales mania. Most of it misguided, most of it wrong, most of it based on the assumption that the reason why the world didn't do V6 is they hadn't sat through enough V6 presentations. So have another. Are you doing it yet? Have another, have another. And I don't think RPKI should do that. It just creates tedium and it's wrong. So the cynicism comes from the fact that I think we're overselling it. That realistically, the package needs more thought. And that's the kind of issue around, should you run all of your stuff from a hosted publication point? Good question. If I'm really worried about being in control of my destiny and my fate, you shouldn't run my publication point. I can't control you. You're one point of failure that affects me that's way out of my control. So I should run my own, should I?
Well, that's the only option if you're saying that.
Right.
You
so let's roll the tape forward and say that 60,000 ASs all run their own publication point, and 60,000 ASs are all doing validation filtering, and they're all trying to pass across this system. Geez, currently it's once every 2 minutes. All of a sudden, you've created a black hole of traffic nightmare because we can't work like this. It just multiplies out to the point of insanity. So what sounds good in the micro doesn't scale to the macro. So should we go hosted? Well, like I said, it scales better. But, the problem is that it's one more place for things to go wrong about me that I can't control. So if my name is Google or Amazon or any always up, the answer is don't go there. Do it yourself. Your fate is too important for billions of users to outsource that and put it in someone else's control. Don't do that. Run it yourself. For the rest of us outside, the big 20 or whatever, are you that important? and that's the trade-off, right?
So right now there is no restriction for you to run your own hosted CA.
I do.
You are doing it. I have my /24. I don't see absolutely no reason to do it. And there are so many other ISPs with a lot of address space. They are not doing it. But don't you think there should be a barrier that, okay, if otherwise there will be 60,000, as you say, there will be 60,000. Thanks to Krill, now it is so easy to do hosted CA that anybody can do it. If everybody decided to do it, the server I'm running my relying party software is going to melt. So
in the very early days of the IETF, one of the guys who spent a lot of time at Bell Labs and UUNet, Mike Odell, he was on the IESG for a long time, and he had some really good things to say at the time. I'm talking early 90s, really, I guess. And one thing he said resonated. The one problem with the internet is scaling. And no matter what you dream of in technology, the question you have to ask yourself is, what if everybody did it? And this is the question we're asking right now of this kind of technology. Because the models we're talking about, what if everyone did it, it just doesn't work. And we have to go into compromises to make it work. Then the next question is, why are we doing it this way that becomes an important question? Because what's going on is that we're delivering a just-in-case model of the universe of all these credentials to every single router that wants to do it all of the time. But there aren't that many updates in the world. There aren't that many things. You're giving them the entire universe so they can check an atom or two. And the only atom they're checking is actually the atom that gets changed, the updates. And so then you've got to ask yourself as an architecture viewpoint, did we get this wrong? Should we have attached the credentials to the update? I run an HTTPS session to your web server, Aftab. to make it work and for me to understand that I've got the genuine website, ISOC or whatever, I don't carry the billion or so issued certificates in my poor machine. It would melt. In the session where we open, I do an exchange, you hand me credentials. I have a small set, even that's too many, but a small set of trust anchors, and I just check you, no one else, just you. I don't have to carry the universe with me to make TLS work. Why do you have to carry the universe with you to make BGP updates work? And that's a really good question. And that I think demonstrates again what I'm saying, that DHS money had a time ticking bomb, tick, 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 no money. And the rush to get something out in response to that program money, I think overwhelmed what was actually a really big design debate about how you make scalable, secure systems. And we kind of pushed all that to one side and said, got to get product out the door.
Okay, so if I stay with your analogy, right? If for example, just hypothetically, I give this checking all the validation part to Cloudflare or to Google, and I only check every update with them rather than getting all the updates myself and then checking it. I just check it. I mean, they have the resources, they have computational power to do everything, and I only check with them. Is it the same model you're talking about with the HTTPS?
I'm not sure I follow you in terms of making that viable and work. You're saying that I open the filter list of my active router and let Google play with it. Yeah, great, thanks, no. For the same reason as one more thing to go wrong, no sane operator would ever do that. It's like handing me, the passwords and credentials to log into their router and cause havoc. You don't do that. However, implicitly, as we said before, if I'm a stub and my transit does it, that's sort of what's happening, but in a different way. The routes that I get from someone who validates is just the routes that, they believe, meet the criteria. Either they have none, or if they can be proved, they're provably valid. And the ones that are provably invalid, if that's a term, have been discarded and I don't get to learn them.
Okay, so there is one question asked by Wilson. He said, delegated RPKI chains have proved to be a problem for some validators to correctly follow. Two cases I have seen in the production where ROAs are missing a router's validation database simply because the validator cannot pick VRPs from a delegated source. Please comment on this.
There are cases, there are a number of validation engines out there and a number of folk have run them all simultaneously. And there are issues when, of course, they get different answers. And this bears out what I was saying earlier. You don't know what is in the universe. And so when your software runs through and picks up what it thinks the universe is, you don't know if it's the entire universe or not. You have no assurance. And having everyone trying to do this all of the time creates some issues. Sometimes there's a really good page on Wikimedia. The repository publication point seems to have been built out of molasses. It takes minutes to establish a connection, and your validator, which is doing a serial walk, kind of gets out of sync and loses the track because someone else is really slow. And so all of these things come into the fact of, why did we build an out-of-band credential distribution system? Why? Because we wanted something rigged up to prove a concept? Yes. Because it's what we should do in production? God, no. It's entirely wrong. It's just, how fast should updates flow around the network? Well, as fast as BGP. How fast is that? You only get to know if you put it in BGP. Yeah, otherwise you don't know, right? It's the same as TLS. Deliver the data when you need the data. Don't try and second guess what BGP is doing. You'll get it wrong.
So on the same point, what Wilson was mentioning, we have seen some problems recently where some validators behaved differently from other in case of a problem. We have been hearing, I mean, yesterday I was on a call with Philip Smith and Ben Madison and Mark Tinker were mentioning that iOS XE still have the same problem they have been facing for many, many years. So you think the OS vendors and the validators who are writing the code for the validators, they should strictly follow the RFC, or they should adjust according to the needs of the operators?
Should you go insane and head off the tracks, or should you try and adhere to the principles of interoperability in one large network, is really what you're asking me. And the answer is stay on the tracks, dude. We found when we didn't tightly specify stuff and left it to the creative skills of programmers, that we found that programmers are both incredibly creative, but all in different ways. And the best example I can give you of precisely that was that we were harangued for years in the IETF that we must never standardize NATs, because NATs were such misbegotten spawns of some demonic god that we should never standardize it. And so what we found is that every programmer built the NAT differently. Even the same vendor, different models behave differently. And even the same model, different runs behaved differently when they came out of the factory. Now, the result was, oh my God, so many NAT traversal protocols, so many that didn't work. Teredo, Microsoft's effort to actually get through NATs, had a 35% failure rate. And that was because programmers didn't have an RFC and went creative. And you're asking me, for RPKI, should programmers leave the tracks and get creative? And I would say, sure. Consider disaster when you say that answer, because you're inviting disaster.
There were so many opportunities left, I would say, opportunity or loopholes left in the RFCs where you left the room for the programmer to...
Well, even now, I did some work on how often should a relying party basically do a sweep through all of the published data. There is no guidance. So some implementations use 10 minutes, some use 2 minutes, some use 1 hour, some use 2 hours.
As per what Randy and his other researchers did, it was some were 60 minutes by default, and 30 minutes as well, as you said, yes.
Right, so then I started bouncing validation up and down, valid, invalid, valid, invalid, to see how quickly the world learned. And it has some kind of interesting results, that if you think you can create an attack mitigation by changing your RPKI on the fly to mitigate the attack, think again. Because that step from valid to invalid, the world takes at least 30 minutes to learn. 30 minutes. And so the reason why it takes so long is that as long as people still know the bad route, even if a few of them disappear, the bad route's still out there. And you've actually got to wait for the slowest to withdraw to actually pull the route out of the entire routing system. So because we didn't specify anything, the system is actually unbelievably slow. It just doesn't work very well because we didn't specify it. Should we have specified it? Well, in retrospect, probably, but I would actually argue you're putting lipstick on the pig. The pig is the out-of-band credential distribution system and this weird form of pseudo flooding. Trying to perfect that is in so many ways wasted effort. It's always going to be a pig. I'm sorry. It's out of band doesn't work.
So, okay, so that's, I mean, good to see Ben is there, and he's saying, unfortunately, manifest handling, it way under specified in 6486. This question has become update the BIS and then implement the changes, or B, fix the software, then update the BIS to reflect the revised behavior. I mean, it's a chicken egg problem, but uh, I totally understand. But what you are saying, I understand that we are trying to do a cosmetic changes, but those cosmetic changes are required right now. Otherwise, whatever we have is broken.
Right, but now we're
And then
spending all of the working group effort.
Yeah, and then you and the other people who started and who gave us what we have right now can go back and
well, we're not doing that. You know, we're spending all of our effort perfecting the lipstick, and the appetite in the IETF to revisit some very, very painful debates and actually admit that we have to change BGP, admit that we actually have to think seriously about how you do credential flooding in band is actually really, really hard. And nobody in the routing area, nobody has the intestinal fortitude to go back and fight again.
So why not just leave the CIDR ops make those operational changes, and you bring back SIDR again?
Well, that was the grand plan, but there's no appetite to do it. So what we find is that architectural things like ASPA are sitting inside CIDR ops because there's nowhere else. And again, the routing ADs have changed, but I think the finger of attention here, the management of this problem in the IETF, unfortunately sits with the routing ADs. And I would go back and go, guys, you're dropping the ball here. It's a really distasteful thing. It's really difficult to bring this back. It was a tortured debate then. It will be tortured again. Nobody wants to do it. But we're not doing anyone a service here by, you know, trying to dress up the pig with more and more effort, because it's always a pig.
Okay, but that pig is still solving a problem, I would say. It's still solving a problem. Very minute, very small, but it is still solving a problem.
Well, it's solving the own goal problem. And like I said, cure and disease, these are all just own goals. So malicious attack, easy, as easy as ever.
As one of our common friends, Geoff mentioned it quite recently, that if you combine with this, with multiple other technologies or the processes to mitigate the issues, for example, the peer locking, for example, if the ASPA comes in, these are the things, if you combine them together, they do solve a lot of problems. Not in entirely the routing security problem, but they do solve many problems, not all of them. The biggest issue we still have, I mean, okay, before I go on to the next one, do you agree on this statement or not?
No, I don't buy it. I just don't buy that. No, I don't agree. I actually think we can do a better job. And so I actually don't think a pastiche of various little bits and pieces and trying to think that somehow most of the important gaps get covered in this pastiche of measures is actually very good. We don't have any kind of uniformity of view. Some folk do, you know, routing DB entries, some folk do rows, some folk do this, some folk do that. And gluing them together doesn't make the whole much better than the weakest link. It's still, oddly enough, a pretty weak system. And to my mind, that's a lot more work for operators and with very little marginal benefit increase. I think the technology side has to be better thought through. I actually think we need to do a better job. But oddly enough, without the DHS to kick us in the collective pants, we'd rather noodle around on the cheap, doing cheap, hairy solutions to little problems than actually making large-scale investments in what is the technology, if we're actually allowed to change BGP, allowed to alter the way we actually carry credentials, allowed to actually use the fact that because BGP is TCP, there's memory at both ends. I know what I've told you. I know what you know. I don't have to repeat myself. And so if you started to work on that basis, I think you'd actually have the idea of just-in-time delivery of security associated with updates. And at that point, you actually then need to look at the way in which updates work around the network. Because if you bring this back to the originator and closer, no one else has to do anything if the originator is causing the problem, yes?
Absolutely.
And so you have to think about, what does partial adoption really mean? What are the critical points here? How do you want to move this around? Have we done this before? Yes, we did. We went through all that thinking with 4-byte ASs. All of that thinking. So this is hardly a new thought. It just needs to be there as a thought process.
Okay. Again, I will stick to my statement. I know you do not agree with it. Whatever you gave us, because I'm going to blame you for that. You, Randy, Dr. Stephen Kent, and our beloved friend, George Michelson. You are responsible for that. You gave us the solution. Operators, I'm not an operator anymore, but I still wear a small hat as being an operator, that it solves problem. And in combination with other techniques, it solves a lot of problem. And as Ben mentioned, it makes the hijack much more difficult. It is still possible, but it makes much more difficult in a fat finger situation, right? And with the peer locking for big tier 1, if that statement is still true, but the big tier 1 operators can actually do the peer locking and solves more problem for us. For me, I tried that for the APNIC event, sending out an invalid prefix out of Sydney, and it was instantly blocked by Telstra, and I tried to do it like 2 weeks ago, because my service provider is connected to IX Australia, who are doing invalid drops. I couldn't even leave Sydney.
So I still think we haven't thought this through enough. So let's look at a ROA. What is a ROA? It's an authority by the prefix holder to permit, to authorize an AS to originate. I can put out a ROA for any AS.
Absolutely.
What does the AS have to do to say, I accept your implicit contract?
Nothing.
Why shouldn't an AS publish an object that says, these are all the prefixes I originate, signed me, independently of the ROA? Because this is the AS saying, signed by the AS. This is the maximal extent of crap I'm going to originate. If you see anything else coming from me, Telstra, drop it. It's not me, it's fat finger trouble. Wouldn't that solve, geez, a whole bunch of route leak problems, almost instantly? Of course it does. So could you use all the other mechanisms, all of this silly repository systems and so on that we're relying on right now? Yes, you could use all that.
Okay, so it can be, okay, so let me put it this way. This can be just an implementation issue, right? So if I am doing my CA is APNIC, when I put an ASN, if it is not my ASN, they will not accept it unless, if I create a route object for somebody else, they send an email that somebody has added you as a route object, right? Why don't that implementation, they follow the same implementation for creating a ROA?
Because quite frankly, it's a statement by the prefix owner. It's not a statement by the AS. And so prefix owners can say anything they want. They shouldn't need to be constrained. But the issue is that's an authority, right, by the prefix. What you want to do is match it on the other side with what the AS is trying to do. And what the AS is trying to do, if it's going to be, a good AS, the same as it does in the routing databases, is enumerate all of the things it will originate. It does other things as well in the routing policy database, but let's just sort of talk about that one. Here's all the ASs that I originate. That's what it says. And you can actually construct filters based on it. Why didn't we make that a signed object, signed by the AS? So that means, like I said, I can take all the things that you originate. Whenever I see an update originated by you, almost irrespective of the path, right? I now have a way of saying, you shouldn't have announced that because you didn't say you were going to. Bang, wallop. So the whole idea inside all of this is actually moving away from securing routing and moving towards a different idea of trying to limit the lies. Because if I sign, this is all and only what I'm going to originate, it's very hard for you to fake a path with me originating it. Even if there's no rower, you can't fake it unless I said I was always going to originate it anyway. Meh. Is that a lie or not?
But I can still hijack your AS.
You can still hijack my AS.
Along with the prefixes
You're hijacking my key, are you?
No, I'm not. I can't. But of course, if I, yes, I get your point now. Yes. So again, this is an implementation issue.
Well, I'd actually say there's a bigger issue around design, as design and architecture. And this is why, as I said, I think we were rushed to the gate of completion. Everyone was sick of cider. The working group was dysfunctional. The move to throw it into the ops area was as much a move by the ADs to get this troublesome child out of their house and evict them and send the problem gaily over to the ops area ADs and go, it's just an operations issue, was in actual fact, it wasn't and it isn't. We're not ready, but no one was willing to do it any other way.
Okay, so we are almost on the top of the hour. One final question by one of our anonymous attendee. I wish to know who this person is, but can we hear some specific prescription from Geoff with regards to solving the entire BGP validation problem, including path validation? And I'm just adding one statement to that. It should be other than BGPsec, I would say.
Oh, I like ASPA. And I think it's actually quite a subtle mechanism of policy and topology. And I actually think the partial validation, the partial implementation properties of ASPA are actually quite good. And it is a step forward from SOBGP, which was pure neighborhood, because it has this idea of provider customer. And again, if what you want to do is limit the lies, ASPA is a nice lightweight way of doing that. So I think if you had three fundamental parts of credential: origination permission by the prefix holder, the maximal set of prefixes originated by an AS, anything that's not in this set is not valid, and you had ASPA, which says, here are all my providers, which some ASs might not want to sign, but that's what you need to do. Here's all my providers. Then you've got a long way down having a reasonable set that actually does good things, even in partial adoption. Fine. How do we distribute them? This whole out of band, multiple publication repositories, oh God, no. Shorten the chains. Make most of the players who actually put out security certificates, make them registration agents. Shorten the validation paths down to 1 or 2 at most.
What's wrong with RIRs doing that?
Shorten the path.
Okay.
Because what you want to do is put the entire validation chain into the BGP update. Squash it down, right? So now, if you're using ECDSA or some other decent crypto that's quite short, and you're using the 65K BGP update message limit, you can actually start putting these credentials into BGP updates. But I can go further than that because BGP has TCP. So if I've given you a certificate in the lifetime of this session, I'm never going to give you it a second time. You know it because I told it to you in TCP and you act it. You act it, it's yours, right? All of a sudden then I can exploit the property that most updates in BGP are actually updates you've heard before. There's almost no new updates under the sun. Even in 24 hours, you've seen it all before. It's all repeats. So in some ways, I actually need to only give you the new stuff. Only give you the new stuff inside the updates in band. Now, should every BGP speaker have to do all this work? Of course not. Look at SOBGP and think about forwarding this over to a more capable system that speaks BGP that actually has enough processing to do the crypto, and reverse feeds in IBGP black routes. Shouldn't have learned that, take it back. Withdraw this, withdraw that, withdraw that. Meh. All of a sudden you have a number of properties here which are actually quite good. I get rid of the whole RRDP. I get rid of distributed repositories. I get rid of the synchronization, all this crap about who has what, manifests and so on. Don't need it. Oddly enough too, I even get rid of publication points. There are none. BGP is the publication. Folk are in control of their own prefixes. ASs are in control of their own fate. There are no intermediaries, short validation chains. Everyone is responsible for themselves. There's no vast add-on infrastructure that we all need to pay for and operate because it's kind of stupid and doesn't work very well. So if you say, what's my dream? I would actually say, push this back into BGP and stop mucking around. Let's actually play the hard miles and alter BGP. Allow the credentials to be inside BGP. If you don't understand it, treat them as opaque attributes. If you do understand it, a bit like 4byte AS, work on them. And so, that, I think, gives us a much better hope of building a system that scales to everybody. Because the way we're going now doesn't.
So the ASP implementation right now is not talking about all these, what you have suggested.
No. ASPA is one tool. So there's ROAs, there's ASPAs, and there's actually a third tool that no one's bothered specifying, which is basically the RPSL equivalent of, this is what I, the AS, will maximally announce. If you see anything else originated by me, it's a lie. Right? You need those three things to make this work.
So then you combine all three, then you
put them in BGP. You distribute them with the updates that matter.
Okay. So if I look at this picture, RPKI still exists.
It's the authority model.
Yes.
The whole reason why you can make a testable assertion about addresses is because there's a digital key. And the reason why there's a digital key is because that was effectively associated with you when you got that address, because that means it's your key and not my key. It's the uniqueness property put into digital terms.
So, so so Ben's comment is announce or originate as the AS cones draft gives you the former. Okay. I'm just going to back to my question. Is the RPKI still exists? You have ASPA and the RPSL equivalent to tell you what
originating set.
What are you allowed to announce, right? Your originating.
What I intend to announce.
Intend to announce.
Yeah.
You combine them and then you have a complete picture.
Well, as I said, plus this ASPA neighborhood, and ROAs.
But right now we don't have the other two. We only have the RPKI. We can only,
no. You only have ROAs. You always
only have. You not the RP. Okay, let's talk about. We only have ROAs, right?
Yep.
So what we are doing with the ROAs, saying that is just putting a lipstick on the pig, and if we are trying to solve the operational issue, don't you think it's the effort the operators are putting into this in the whole ecosystem, whatever they have right now? They don't have the other two things. They only have one. So whatever the effort they are putting in right now, you're saying that it's not going to work for you.
I actually think there's a lot of effort in hosted or self-hosted RPKI publication point tools and software. And there's a huge amount of effort in the validators. And there's a huge amount of effort on folk to operate that machinery. All due respect, we need to have it done today. And so the folk who are doing it are stalwart people, and my hat's off to them. But in the grand scheme of things, that's not where we want to end up. It's not. We want to be back in BGP. We don't want publication points. We want it to be BGP. We don't want to do this sideways RRDP. We want it to be BGP. So what we actually want is provisioning systems that can use the RPKI as part of the origination issue and create iBGP objects that turn into eBGP that have the credentials attached. The credentials attached in the same way that when you make a TLS connection, the credentials get attached in the handshake. The credentials for this should be attached in the BGP update. And what you want to avoid is making every BGP speaker into a massive crypto engine. Which is why you kind of want to pull this back and use, you know, one per AS or whatever. But you actually want to tie it into BGP rather than perfect all this sideways ornamentation of distributing paraphernalia because we can't touch BGP. Let's just touch BGP and be done with it.
Okay, so just my closing statement and then your last comment. I still would request you and other people who gave us what we have today to go back, rename SIDR, give it whatever nice name you think is going to fly, sit on a table and come up with this plan, which is workable. But meanwhile, let the operators do and play with what they have right now to secure whatever is possible. Do you think is a workable solution?
The problem is it's a bit like the V6 sales effort. It gets oversold. Promises are made. Undertakings are given. Impressions are created. They tend to be oversell.
Okay, as Roland said, we have to go back and fix the V6. I really don't want to do that.
Right, and part of the issue is some of the really basic lessons, and I noticed you and Philip touched upon BCP 38. Some of the really basic lessons about routing hygiene, we can't seem to intrude in the business of being a network operator. And I must admit, I can appreciate that from my own days in an ISP in Australia, a major one, that they had, if you will, the investment bank, the product development bank, and managers would come promising rates of return. Give me $20 million and I'll make 20%. And over the internet, we said, give us $100 million billion and we'll make no money at all. So we never got any money. And it's kind of need more engineers, need more staff, need more people at the wheel, need more bells and knobs. And the answer really was, will this translate into revenue, into more customers, more money, more product? And the answer was, no, it's just doing a better job. And it's really hard inside that enterprise environment to argue the quality of the engineering, almost irrespective of whether the customer values it or not. And this is what we found with BCP 38. It's dead set simple. You know, it could have been done so easily, but the operator said, or at least the network companies said, oh, it's all expense, no benefit. If I don't do it, I'll have the same customers, I'll have the same revenue, but I'll save $1. And our problem is in trying to do these kind of things like security, that it's a market failure. And God help us if it becomes a regulatory imposition. But you kind of wonder if the only way to kick the market into a better stance is to actually create some minimal obligatory standards at national levels. But, you know, for most of the internet, that's evil talk. How dare you regulate, you know, this area? But if the market won't do it, how can we do it? And the other part we find ourselves in right now, if we don't have the impetus to actually create good technology, but end up with stuff that's pushed out the door that is the pieces of a solution rather than the solution, rather than stuff that's actually quite survivable, stable and whole, but just little bits and pieces of it, then it's really hard to say you must do this because, you know, it comes with a manual of operator beware that many operators haven't got the time to read because it's a very conditional statement right now about what the good of rowers is. Very conditional. And a lot of people just, they're trying to make $1, right? And so this is what we're up against here. Should we spend more time and effort back in the IETF factory being a lot more conservative about how we actually call technology ready rather than this constant idea that sending out 80% done stuff, or in Rower's case, about 30% stuff and calling it done, and leaving the user and the poor operator to try and figure out the mess we've created because we kicked it out the door. Whoever said, move fast and break things, was a lying bastard. And I think he did a bigger disservice to this industry than any individual. And I don't care how much he's worth. It was wrong and irresponsible, because by breaking things, we make it so much harder to do the right thing, because everyone's moving so fast, kind of forgotten about that. It's all just broken. Let's move on. And that's the legacy we get given with. So you can sense my frustration and I sense yours. Because what you're saying is, Geoff, stop calling it half-baked. We really want people to use it. And I'm going, oh my God, it's just, not enough. We've got to do a better job. And that tension is with us right now. And I hope if the audience to this podcast or whatever, whenever they get to see it, gets to appreciate the subtleties that go on inside these systems, because they are very large, very complex, and a lot of moving parts, and trying to build it in ways that are robust and withstand accidental and deliberate attack is an incredible goal. It's really hard. And it's been around for 20 years as a problem because it's a really hard problem. We're not dumb. It's just a really hard problem. And the first sort of solution that we think we've come up with that might work is not the last solution. It's just the first. And well, I think we've got to look at it that way.
I cannot disagree on that one, but as you said, from the operator's point of view, let operators do what they are trying to do, and those who can go on the deciding table or the designing table back. I think I would request, I can't speak on behalf of the operators, but I would suggest that you go back and start working from, not from the scratch, I would say, but from where you guys left.
Well, like I said, a lot of knives need to be buried before that ever happens.
Anyway, so let's end it on a nicer note, and I would say thank you so much for your time.
Well, Aftab, it's been a pleasure to debate these issues, because I think the real thing about this is that all of technology is a conversation. The telcos sort of wrapped it up and said, this is the way we do it. It's not a conversation. But I actually think the internet has welcomed a technology that is viable, plastic, malleable, and developing. And it is a conversation. And, if we can continue these conversations, the result is always better.
And it has to be solved by collaboration and listening to each other. We can't box each other at all. I don't think so that we are in a position to say, no, you are wrong, I'm right, I'm going to do what I think is good. So I think more conversation is required. Sure. There is a lot of room for improvement, but the message to operators: create ROAS.
With care. With care.
With care. Don't create invalids. Make sure that you don't forget about what you have created. So on that note, thank you so much, Geoff. Hopefully I'll be talking to you again in 2021. I'm not going to bother you the remaining part.
Well, in person, yay.
So
I look forward to a vaccine, as does the rest of the planet.
Yes, thankfully we can travel within the country. So maybe somewhere in the APNIC office sometime.
Absolutely.
Have a nice evening. Thank you everyone for joining. Hope to see you all somewhere, someplace. Thank you so much. Take care.
Thank you. Cheers.